All right, we're going to continue our inference with two proportions, but we're going to do that now with confidence interval. We just finished an example of two proportion z-test. And so let's kind of review what that problem was because our interval will be the continuation of it. So here was this problem about people who were smoking. And we were investigating if the counseling helped in the success rate in quitting smoking over just, the counseling plus nicotine patch was successful over just the patch alone. So, if you recall from our um, our hypothesis test, we concluded we had a small p-value here. And so we rejected the null and we had evidence to suggest that the proportion of smokers who wear the nicotine patch and attend counseling have a significantly higher success rate quitting smoking than the proportion of smokers who just wear patch only. So then we are posed this question. If you conclude that there is sufficient evidence to say that, the counseling is more effective, then see if you can convince the government to now fund that. Well, to fund those counseling programs, it might depend on just how successful the counseling is above the patch only. Okay, so we're going to complete a 95% confidence interval to estimate that difference between those two proportions and see how much higher or how much more successful the counseling group was than the patch only. So here I have the panic model. So our parameter and our assumptions are the same. And so we're not going to do those again. Those are very long and arduous. But remember that we talked about how we had the P of C. Let's kind of just review what those parameters were. So we said P of C was the proportion of people who wear the nicotine patch and also attend counseling who successfully quit smoking. And then P with the little p subscript is just the proportion of people or smokers who wear the nicotine patch only and are successful at quitting smoking. So let's do our interval. Well, we get to do the calculator on that as well. So we go to our calculator. Well, the name of this, by the way, is a two proportion z interval. Where the other one was a two proportion z-test. So here we have a two proportion z interval, and then we just go and put our information into the calculator the same way that we had done before. So let me pull that calculator up real quick. Here we go. So you're going to do the same thing where you go stat and then arrow over to tests, okay? And you have that whole menu of all of those items. Well, so we're going to stat over to test, and we are then, of course, so previously we had done two proportion z test. Now we're going to look for our two proportion z interval. So don't let that be confused with this number 9 that says two sample z interval. If you went into there, if you hit enter, you can see, look, how this sample is looking for standard deviations and such. This one comes into play with means, okay, not proportions. And so it will specifically say to proportion z interval. So the proportion ones do specifically say proportion. Otherwise, they are for means. So here we have the two proportion z interval, and we're going to put our information in there. And so what we had in there before was, remember that we cannot have this as a decimal value for x. So while the information we had said 32% of the 143, then that we put in as 46 and you round appropriately. So I'm going to do that 46 over 143, and so 46 over 143, and then the other one was 51 or 30 out of 151. Okay. And then we have this C level, which of course means the confidence interval that we are being asked about, and we were being asked to create a 95% confidence interval. So we go and we put in 95, so 0.95, and then you calculate, and voila, it does all the calculating for you. With here is our interval, where there's our lower bound and our upper bound. Now, we must keep in mind what this is saying in terms of the parameters. So this is about the difference between them. We cannot lose that thought. That's why I'm spending a little bit more time on this day going over the conclusions and what this really means. Now, the way the calculator does the subtracting, do you see how I wrote my answer here? I make sure that I define the order that I am subtracting. So here is the difference that we calculated. And the way the calculator does it is it will always subtract the P1s minus the P2s. So since I put the counseling group in first for my P1s, then that's what I have here is P of C minus P of the patch only. And then I have those two numbers. Now, let's think in terms of what does this mean with these numbers being positive. If I am subtracting and these numbers are both positive, what is that telling me about which one of those proportions is bigger or smaller? Well, since it's a positive difference, then I can see the proportion for the counseling is higher for both of these lower bound and the upper bound. So when we state our conclusion, so make sure you state the interval from the calculator printout, but always state the way in which you are subtracting for two samples. Okay, so there are going to be two parts to our conclusion. One is that discussion about the true difference. Okay, this is about the difference between those two proportions. So you can see down here, I am 95% confident that the true difference between the proportion of smokers who are successful is between 2.34% and 22.3%. More successful for the smokers with the nicotine patch and counseling than for nicotine patch alone. Now, there actually is another way that I found myself writing this, and so I'm going to type this in here. So another way that you could say this is if we say, let's see, I am 95% confident. So I'm going to type this in here. So I am 95% confident that the proportion of smokers on patch and with patch and counseling, with the patch and counseling are between 2.34% and 22.3%, more successful at quitting smoking than the proportion of smokers with patch only. Okay, so you can either say the difference is this and this, is this between this and this higher for something. You could also say lower for something. Or you could say, I'm 95% confident that this, the first thing, is this much higher than the second thing. Now, I'm saying the first thing is higher than the second item because the numbers in my interval were positive. So we'll talk about in a moment, what would we do if the numbers in our interval were negative? What would we do if the numbers in our interval had zero? One was negative and one was positive. So we'll talk about that in just a second. But let's address the second item in a conclusion that we need to address. And that actually is whether or not zero is in the interval. and what that implies. So we know that since this is about a difference, the difference between two items, if 0 is in there, then there could be 0 difference. So think about that for a second. So for our 0 statement, we are thinking about the fact that if 0 is in the interval, there could be 0 difference. Okay, no difference in those proportions. And so that's what we have to address. And so that's what the second statement will be. Since in this case, 0 was not in the interval, it was completely contained above 0, then this suggests that there actually is a significant difference. So if it's completely above or completely below, we have evidence of a difference. If it has 0 in it, we do not have evidence that there is a difference. There may not be one. So here are some other situations that could occur. And so I have those all spelled out for you here. So here we go. Let's take a look at those. All right. So what happens if both of the items are negative? I think that's what we're asking here. So there's 3 possibilities. They could both be negative, both be positive, or one's negative and one's positive. So here we go. Always define the way you are subtracting, proportion 1 minus proportion 2. Okay? And so if they are both negative. Now, I have found over the years that it is easiest if you just always think in terms of the first item. So if in this case, the first item is the counseling group, if they are both negative numbers, then the first item is between this much and this much lower than the second proportion. So if they are both negative, that would mean that the entire estimate is having P1 less than P2. Okay? And so, for example, I have over here on the side, I am 90% confident that P1 is between this much and this much less than P2. All right, I think that is intuitive and makes sense. But what if they're both positive? Okay, then, of course, that means the entire estimate interval has P1 more than P2. So I am 90% confident, if that's an example, that P1 is between this much and this much percent more than P2. Okay, all right. So those are pretty intuitive. Here's one that's a little bit more unusual. What happens if there is one of them, the numbers is negative, and one of the numbers is positive? So let's talk about that. Down here, if one of the numbers is negative and one of the numbers is positive, then here's what that's saying. The P1 could be lower than P2, but it also could be higher than P2. We don't know. We don't have a definitive answer one way or the other. Could be more, could be less. So therefore, we do not have evidence that P1 is clearly lower or more than P2. All right, so here's how that might sound. Let's see. I guess I did not write that. Oh, here I liked. Okay, here's how I do that. I always, again, think of in terms of the first item. So we have the negative number first in the interval, and so I would say something like, I'm 90% confident that P1 could be this percent lower than P2 up to this percent higher. So in fact, I kind of want to change this up a little bit and say, how about this? Let's give you another option. See, this is what makes my job as a grader so fun because there's all these options. So I can say something like this. P1 is between, this percent lower than P2 up to, okay, uh, this percent higher than P2. So P1 could be this percent lower than P2 up to this percent higher than P2. So you have to be real careful about your thans or your ofs or your all those kinds of things. Now, again, since 0 is in that interval, that is going to further suggest that there is not a significant difference. 0 in the interval could mean 0 difference. I'll say that again. 0 in the interval could mean 0 difference between those proportions. Okay, now here's an alternative wording. Just wanted you to be aware of this, and you can certainly say this, but here it's written that you could also just talk about we're this percent confident that the true difference between the two things is between this much and this much, lower or higher. Okay, and since 0 is not in that interval, then this further suggests that there really is a difference. Okay. Then, of course, I already did this one down here. We are blank percent confident that that true difference between them is between this much higher or lower to this much lower or higher. Okay, just got to get it straight. All right, those are those conclusions that are the trickier part. You've really got to wrap your head around those wordings for the intervals. Now, the final component to this is understanding and recognizing the formulas. This is what's going on behind the scenes when your calculator completes the computing. And we don't, like this is what the calculator is saving you from having to do by hand. We are not having to get the z-score with these two proportions. See, look, for one proportion, that's not a big deal, but look at how hefty this gets with two proportions when we're talking about the difference between them. Look at our standard deviation, quite involved. Okay, so lots of different things happening there. So I have for you down here an example where I want you to look at those numbers and for it's for making an interval. Okay, so they've started it out with the parameter, and remember that to make an interval, we have our actually statistic, okay, and then we have the plus or minus, okay, and then we have our critical value, and then times that standard error of the statistic. Okay, so that's what's happening right here. For two proportions, our statistic is the difference between them, P1 minus P2. Okay, plus or minus, here is that critical value, so we could figure out how confident that is, and we're going to do that in just a second. And then look here. Look, this is that standard error because it's using p hats. It's called standard error because it's using the p hats. And see, that's coming straight from this right here. Okay. So I just need you not necessarily to actually put these numbers in and compute them by hand because we're using our calculator to do that. But I do know that you still have to be able to recognize these formulas because I've seen them in multiple choice questions. That's why I'm posing this to you and showing it to you so that you could then kind of identify the pieces of what that might be. So in this problem, you can see clearly then that this p hat or the P1, the sample proportion we got for the first group was 0.867. And look here, here was that sample size of 2023. P hat number 2 was 0.755 because see, it's doing P1 minus P2. And then sample size was 1935. Now, how about that critical value? The critical value is a positive and a negative 2.326. So what confidence level is that? That's what I'm asking you here. So remember, confidence level is what's in the middle. So we're going to do our little thing right here where we've got this negative critical value to the positive critical value, and we're going to compute this area in the middle, and that's norm CDF from the negative to the positive, and that's 0.97998. So this was a 98% confidence interval. All right, I think that's the notes. So now you are going to practice 2 of these panic models and then apply your understanding of the interpretations, work on the interpretations and the language that you would use for all of these different ways that you would say what your interval means. Very important that you get those. And that connection to statistically significant difference or not. All right. So good luck to you on your day 6 assignment.